Welcome to another video as part of the Pavilion video series. SQL Server Workload Distribution. This is part 2 of 3. It's focused on the physical storage load balancing. So when modern storage architectures can help you make the most of your database platform investment. So I am Kostas Apopoulos, the Chief Field Technology Officer for Pavilion Data. I'll be joined by David Klee, the founder of HeraFlex Technologies, our SQL Server consultant and deep SQL Server expert. So in this video, we're going to focus on how those modern storage architectures like Pavilion can help you make the most of your database platform investment. We're going to focus on things like storage latency perspective, the performance tuning seesaw, SAN controllers, metadata management, database workload and random I/O, as well as workload distribution. So before we get into the presentation and an introduction of David, let's talk about Pavilion and how Pavilion unleashes the power of Windows and SQL Server. Of course, we work well for every single workload, but if you have super high bandwidth per host needs with ultra low latency, this is where we really shine. Whether that's large or small block sizes, whether that's read or write. Specifically, that relates to SQL Server. So that Pavilion platform that has impressive IOPS and the millions of IOPS and the impressive throughput, but what is most impressive is that latency in the range of 100 microsecond read to 25 microsecond write latency. All of that packed into 4 rack units and over 2 petabytes of usable capacity. Whether you're leveraging that platform for a Windows environment running SQL Server on bare metal, leveraging NVMe-TCP or NVMe-RoCE, we have certified drivers from Windows to support both of those environments. What's really impressive, you can get similar or same performance of bare metal inside of VMware running SQL Server in Windows, leveraging VMware 7.0 and Pavilion support for NVMe-over-Fabrics RoCE for VMware 7.0. So whether it's bare metal on Windows for Windows or whether it's virtualized inside of VMware, incredible performance, but ultimately low latency, which drives incredible results for SQL Server. So our presenter today, I'm excited to introduce the founder of HeraFlex Technologies and Sequilibrium Education, David Klee. David is an incredible performance tuner, enterprise DBA, and infrastructure architect, and self-proclaimed geek. David's expertise in SQL Server and VMware are the best I've seen. His ability to intersect the storage, the software, and the virtualized infrastructure or non-virtual infrastructure, and to tune the system to get the most out of SQL Server is incredibly impressive. So with that, I'll turn it over to you, David, and let's learn more about SQL Server.
Thank you, Costa. When we start talking about the database infrastructure stack, or really a data platform as a whole, there's a ton of moving parts in here. You've got the storage, you've got interconnects, you've got physical machines, you may have virtualization in there, you've got the VM architecture, you've got an operating system in there, you've got the database storage engine, you got the databases, you got file groups. Oh my, there's a ton of stuff in here. Wildly complicated. The biggest challenge that I find is that when one layer of telemetry is saying everything is absolutely terrible, and then you look at the other end of the stack and everything is good, well, who's right? Problem is, they're both right, because there's a lot of stuff in the middle there. The tuning of these layers get really interesting, and it's honestly kind of a seesaw, teeter-totter sort of environment. You can start tuning more for the database storage engine, but if the physical architecture isn't there, or everything in between isn't lined up, you end up with a challenge. So what we have to do is really figure out, tune a piece, monitor the platform, figure out what changed, tune again. The bottleneck is going to swing back and forth in all of these different layers, and my goal is to make sure that the database is the primary bottleneck to performance, specifically the database code, and not any of the infrastructure components underneath. These are really complicated beasts, and they take a lot of TLC over time. You know, to quote a good friend of mine, the clothes that fit your child when they were 2 don't fit when they're 10. These have to be managed based on the scale and the demand and the business requirements of these things. The storage layers can be the primary bottleneck, and historically they really are. When you're dealing with database instances like this, it's not just one database that we have to worry about. It's a lot of them across a lot of SQL servers and a lot of virtual machines. And when you have this highly concentrated of a very demanding workload, you end up with some insane random I/O patterns. And a lot of times, your storage layer is simply pushed to its limits. And then everything chokes behind it. And you sit back and go, whoa, this is not good. This is not healthy. So then, what do we need to actually do about it? Well, we're going to focus in on the SAN first. Not all SANs are created equal. Traditional SAN architectures, you've got a couple of controllers that deal with metadata management. Historically, these are not multiple active controllers. I hate the term active-active, but historically you have an active controller and the other controller is going to be passive. It's there just in case something fails or you need to fail over on the first controller. These are not the strongest of compute devices. A lot of times the CPUs on them will actually choke and become its own bottleneck. So the metadata management of literally looking for the data that you're asking for becomes the biggest point of contention and slows the whole thing down. And then there's controller memory. A lot of times we can have controller cache memory, which is just simply insufficient for the workload because the underlying storage is slow, and the whole thing slows down again. And then there's the disk pools, which, if you're dealing with spindles, may spinning rest in pieces at this point. But even if you're dealing with SSDs, sometimes the disk pools themselves just simply can't keep up with the demand. But a lot of times, the controllers themselves are the biggest bottleneck to performance, and not the actual underlying SSDs or NVMe. So we take a look at that SAN, more of a holistic approach. We've got multiple controllers on here. One is active. We've got a lot of activity coming from the different database workloads, and it's all being funneled into that one controller. The CPUs on the controller can choke. The interconnects can choke. The cache memory can be overwhelmed. And then the disk pool itself can be overwhelmed if the controller isn't already holding it back. You end up with a perfect storm where the whole stack, the whole reason to manage the data is sluggish, and it's not keeping up with the speed of business. Unfortunately, those points of contention are very normal. So now, take your big database workload. It's highly contentious, it's got a large block size behind it, and a lot of these SANs just simply can't keep up. The large block size, the high rates of throughput, the high IOPS demands, it can literally push these things to its limit. Leverage the SAN's capabilities, and let's work on spreading out this workload. Let's spread it out as wide as we can so that we don't hit any inherent bottlenecks. When you take a look at multiple active controller architecture, things get really interesting. It's still highly available, it's still redundant. We're going to look at more LUNs, and then we're going to talk about more SQL Server object distribution because you end up with better concurrency, better action parallelism through the entire stack. So take a database. Take a proper SAN. Lots of controllers, more redundant, more disk pools, less metadata to manage, more horsepower behind this, more speed of interconnects. Get this into a very high-speed environment. Get more LUNs. You don't have to go crazy, but we do want to spread out this workload to the appropriate number of controllers. Now take your database. We got the transaction log on one, and you can only do one of those. But if we have a lot of different databases on there, we can spread those out as well. Then take the file groups. Primary file group, multiple data file groups, maybe non-clustered indexes, maybe data that is constantly colliding, or we've got partition data that we can spread out, or maybe two commonly joined tables, we can spread those out and have better concurrency. So lots of data files. Spread them out appropriately. Use perfmon or iostat to go figure out your storage distribution in there and make sure the stuff works better. But if we can spread this out, the database engine's going to work better. The SAN can handle it better. Your interconnects can multipath the stuff better. You end up with better performance. It may be a few more objects to go manage, but so what? It's pretty straightforward. Get better performance. Because if we can spread out this workload, and spread it appropriately across all of these active devices, everybody wins. Do this properly. But by doing this, you have to understand this database workload. One of these architectures may work for one system, but if the database action on another database is single-threaded or poorly constructed, you have to understand the parameters of these things in order to go do this. So like I said before, it could be large tables. We've got billions of records in some of these tables. It could be commonly joined tables, like order history to customer information. It could be different partitions. It could be colliding objects, like we're loading data into staging tables. It could be we've got TempDB just going absolutely berserk because of some of the work that people are doing incorrectly and slamming TempDB when they shouldn't be. Manage this stuff both at a micro level and a macro level. If you manage this stuff properly, there are a lot of the same practices can be applied everywhere. And then you get a lot more surgical with the individual workloads that really demand it. In all of my years of SQL Server engineering, storage latency matters more than anything else. This is where I see Pavilion fitting in. It scales, the NVMe media, the PCI switch architecture, the multiple active controllers, all of it matters. Costa's going to show some performance numbers that you really might not believe, but take it from me. I'm an independent consultant designing some of the largest systems in the world. Thank you. This thing works. I love the opportunity to share absolutely nerdy details about SQL Server data platforms. Back to you, Costa.
Thank you, David. Great insights as always. As we summarize this video, let's bring it back to something that's really core to SQL Server, latency. So as we look at a Pavilion storage array, it's always sub-microsecond latency, whether that's bare metal or VMware, whether that's read or that's write. Impressive latency drives lots of things upstream to SQL Server that are all good. It pushes the bottleneck from the storage to somewhere else inside a SQL Server ecosystem. So we have demonstrated through this table that is a disk speed on Windows with a single Windows host and a single NIC. Some very impressive latency, whether that's Windows bare metal, the first two columns, Windows TCP and Windows RDMA, the read, and then the first two columns on the right. But what's equally impressive is the latency by taking that same ecosystem and put it inside of VMware. Similar or same latency, or in some cases better depending on the protocol than bare metal. So as we see, latency is key to SQL Server, and Pavilion can deliver impressive latency, bare metal or inside a virtualized VMware ecosystem. Thank you so much for spending time today with us, learning more about SQL Server and how to optimize the SQL Server ecosystem to get the most out of your investment. Special thanks to David Klee, our SQL Server extraordinaire. We appreciate all the partnership and all your insights you've given us today. If you want to learn more, come check out our other videos at www.pavilion.io or reach out to us via email at info@pavilion.io, or of course you can always call us on the phone. We'd love to talk to you about how Pavilion can help you optimize your SQL Server environment and get more out of your investment. Thank you.